Friends, welcome to this video session. The topic that we are going to cover in this session is bonding in carbon and its versatility. So friends, before we move ahead with our discussion, we should know that the atomic number of carbon is 6, which means that a neutral atom of carbon contains 6 electrons. How will the distribution of electrons in different orbitals of carbon occur? But friends, why are we studying about the electronic configuration? We are studying its electronic configuration so that we can understand the type of bonding in carbon. Carbon has 4 electrons in its outermost shell. So it should either lose 4 electrons or gain 4 electrons to achieve noble gas configuration. But really, is it possible? As carbon is a small atom, so outermost electrons are held strongly by the nucleus of the atom. So it is not possible to remove 4 electrons from carbon. Also, it is not possible to gain these many electrons due to energy considerations. Let's assume if it were to gain or lose electrons. 1. It could gain 4 electrons forming C4- anion. But it would be difficult for the nucleus with 6 protons to hold on to 10 electrons. That is 4 extra electrons. Second, it could lose 4 electrons forming C4+ cation. But it would require a large amount of energy to remove 4 electrons, leaving behind a carbon cation with 6 protons in its nucleus, holding on to just 2 electrons. Carbon overcomes this problem by sharing its valence electrons with other atoms of carbon or with atoms of other elements. Carbon atom has 4 electrons in its outermost shell, so it requires 4 more electrons to achieve the noble gas configuration, which it gets by sharing electrons. Since one carbon atom requires 4 electrons to achieve the nearest noble gas configuration, therefore, it has a valency of 4, that is, carbon is tetravalent. Not just carbon, but many other elements form molecules by sharing electrons in this manner. The shared electrons belong to the outermost shells of both the atoms and lead to both atoms attaining the noble gas configuration. Before going on to compounds of carbon, let us look at some simple molecules formed by the sharing of valence electrons.